Voltage transformation is the most basic function of transformers. Understanding the principle of voltage transformation is important, and it involves the phenomenon of back electromotive force, induced electromotive force, in coils. Coils produce back electromotive force proportional to the number of turns and the rate of change of magnetic flux. Transformers utilize this property to convert voltage. Transformers consisting of coils wound around a magnetic material called a core can be considered as a type of coil. Notably, transformers have two sets of coils, primary and secondary, which are magnetically coupled through the core. When a current flows through one coil, it induces the same strength of magnetic flux in the other coil through the core. For example, if the primary coil N1 and secondary coil N2 have the same number of turns, the voltage on the secondary side is V2 equals N2 times dph divided by dt, resulting in the same voltage as the primary side. However, if the number of turns on the secondary side is 1/10 of that on the primary side, the output voltage on the secondary side becomes 1/10, as 1/10 is substituted for N2. The relationship between voltage and the number of turns is represented by the formula V1 over V2 equals N1 over N2. From an electromagnetic perspective, this phenomenon can be interpreted as being based on the back electromotive force of the coil. Voltage transformation is utilized in various situations, with the most common example being pole transformers used to supply commercial power. The principle of voltage transformation in pole transformers is very simple. By changing the turns ratio between the primary and secondary coils, high voltages such as 6,600 volts are converted to low voltages such as 100 or 200 volts. However, there are several constraints to consider in order to effectively function as a transformer. One of these constraints is magnetic saturation of the core. In the case of devices handling large power like pole transformers, large currents also flow through the primary winding. If the current is too high, the magnetic flux inside the core becomes too large, leading to magnetic saturation and consequently causing a decrease in the secondary voltage, that is, the commercial voltage. Therefore, it is necessary to use a magnetic material with a high saturation flux density in the core of pole transformers. While the explanation was based on pole transformers, the same principles apply to high-frequency transformers used in switching power supplies.